Okay, so yeah, welcome everyone. I'll try to make an overview of essentially the use cases where it's worthwhile to use knowledge graphs, and those in which you probably should think of something simple. Then I'll try to give you our thoughts and our vision on what is really special about this space and about this technology, how it actually works. Then we'll jump to the application map, which essentially tells the story of how content management, data management, business process management, and a few other related areas can benefit from this technology. To jump after that to another map of capabilities, which is like what are the capabilities that the knowledge graph platform should have to deliver and to meet the requirements of all these applications. And then at the end, as part of this graph management capabilities map, I'll also make a quick introduction on the agenda for the next couple of days, so that you can get a better sense what to expect and how the different tracks work. If we have the time, I will also talk a little bit on the fine print, the small print that you should be careful about when you adopt virtualization, sharding, and some other technology. So let's get it moving. Well, let's think a little bit on what these 5 or 6 problems that I'm going to mention now have in common. So one of them is monitoring all the IT systems in a huge retail bank to try to do really good risk analysis and root cause analysis, or having a platform for market intelligence for oil and gas trading, or again in the market intelligence space being able to build a knowledge graph of all the M&A transactions on Earth and all the companies that matter, and then classify and derive analysis by sectors, by regions, and all sorts of slicing and dicing. In a very different area, this is another problem of building management systems. So that's the software that takes care that the lifts and the ventilation and the lighting and the heating, they work in synchron, and the building is operating fine. And finally, the problem of searching, finding relevant sections in really long, like 600-page long clinical trials for drugs. Well, what all these problems have in common is that, well, they are a good target, and we've been successful in addressing these problems with technology based on knowledge graphs. And what they have in common is that in all these cases, you need some sort of unified view across different types of information. So you have to combine multiple databases within the enterprise that have been developed without centralized control. And you quite often have to mix and match what the data that you have in the databases with information that you got to extract from text or from unstructured content or something else. And then the biggest challenge is when you have to combine your proprietary knowledge with data that you are buying from somebody outside the organization, or just open data or open knowledge bases that you can use. So that's quite a challenge to put these different types of data together in a sustainable and consistent unified view. And it gets really even harder when you have to solve these problems in domains which do require, let's call it, comprehensive domain knowledge. And what I mean by comprehensive domain knowledge is, think of a domain where you need to be aware of more than 100,000 concepts in order to make a good recommendation or indexing application, or a domain where the so-called reference data is very, very highly interlinked. So if you take the company domain and the M&A domain, and you draw all possible relationships between these companies, you end up with a very, very hairy graph. And that's an example of a case where you have a highly interconnected reference data. Example of case where you have hundreds of thousands of concepts that the system should be aware of is life sciences. A very, very obvious example of this. And finally, there's such domains and such applications which require paying attention to the type, to the specifics of each and every relationship. So you rarely have the question of is this person related to that company, or is this product related to this subject? The question is quite often much more tailored to what are the relationships, what is the semantics of the relationships that connect to and that's something that requires proper modeling of the semantics, because the relationship between a chemical substance and a drug could be the one that it is the active component, or could be that you should never put this chemical compound together with this drug in your body, and these are very, very different relationships. So if that's not your case, if you don't need to build such unified view, and if you don't have a knowledge intensive domain, then you should probably think of something simple that can address your problem. So you can probably go ahead with some sort of graph engine that is tuned for graph path search, or with one of the many document databases that all pretend to be the universal enterprise database, while it's all about moving XML in and out, or JSON. And many of these problems can also be addressed, as they were for the past decades, by database management systems, relational database management systems, or even with one of the modern search engines, starting from Lucene to Solr to Elastic. If you don't have to deal with a knowledge-intensive domain, and if you don't need to put some data together, there are simple ways of doing things. But if you are still with us, well, thank you. And yeah, let's talk about these applications that really make difference for knowledge graphs, and what it takes to deliver them. So what's the added value? Why we are all here? Why you dare to attend a conference called Knowledge Graph Forum? Our central at the center of our understanding that the most important thing for us is that knowledge graphs serve as hubs for data, metadata, and content. All sorts of data and metadata, and part of the magic is that to put this stuff together in a knowledge graph, these all the data, metadata collected from different sources is enriched with even more semantic metadata that glues these different concepts and these different types of data together. Because metadata could be everything, and there are tens of different types of metadata that could be useful, all the way from descriptive metadata to operational metadata to provenance and other things. So what is that makes knowledge graphs so different and so much better than any other data management paradigm that you can choose for this task? One of them is explicit semantics. When you have to put together information from different systems, all these different systems, you have a CRM system, and then you have an ERP system, and then you have 5 other systems in your organization that have different logic behind them. So when they manage a document, they mean slightly different things, and the attributes are slightly different, and all sorts of dates that you have to manage about a single document across these different systems are slightly different. And you need a model, you need something in the middle that allows you to put these things together by aligning the semantics of the different dates that come from the different systems from one and the same document, rather than just amalgamating them in a useless mash. Then the other thing is a really universal, all-encompassing data model, and that's the RDF model, which is really as expressive as it could be to allow you to represent all sorts of flavors of data. And last but not least, one can hardly underestimate how many problems were caused by not having unique identifiers. And with knowledge graphs, you have them, and that's a very important part of the picture. So to sum it up, how the knowledge graph magic work. Point one, you have to put the data together, because this linking is about putting things in context. And the way in which people deal with context is because in at a much lower level in our heads, in the neural networks, connect different concepts and neurons that represent different concepts. So when you have two entities which describe each other, well, they both have better description compared to taking their descriptions in isolation without the reference. So conceptual networks, when you have plenty of concepts or entities put together, they allow for much better interpretation of these data and application of much more interesting algorithms as compared to what we can do with tables. So if you get this to the next level, and if you have a really critical mass of concept or entity descriptions together, let's say 2 million, and that's what you really need in many domains, well, that's the level of the knowledge of like PhD student that is just finished his work and knows more or less all the important things in this domain. So interlinking data is about putting data in context. And once you have data in context, you can apply algorithms like centrality and relevance and many other things in a much better way as compared to dealing with tables. The second thing is semantic metadata. So provide rich descriptions about the data coming from different sources so that you can use them together. Because speaking of diverse data, this just means that these are data which are developed separately in separate systems for different purposes, most probably in different divisions in your organizations. And these different data sources, this data is meant to be used in different contexts. And each time when you use data outside its primary context, there is a chance for misinterpretation. So the only way in which you can use diverse data taken from different contexts without misinterpreting it is to have very clear specification of the meaning. And I'll give you again this example. What does the different dates that has something to do with one document actually mean across the different systems, so that you can really take the benefit of fusing these data and using them together without getting the negatives of misinterpreting a lot of stuff. So finally, there is one more thing that knowledge graphs can do for your data, and that's to marry and to improve your proprietary data using global knowledge. You can't just download DBpedia Wiki data or geonames and take some competitive advantage, because that's what everyone can do. But global data and public data or commercially available data can improve your proprietary data in several ways. They can enrich the data so that you don't have to maintain your own tables with all cities in the United States or North America or Latin America or Africa. That's worthless. They're very good quality geospatial databases that has all the information you need about all sorts of geographical locations, and you better use them rather than having one flow in your IT organizations of people who just take care of the geospatial aspect of your own database. It just doesn't make any sense. So that's one example of how you can link and enrich your data, which is what is really proprietary for your organization, with stuff that you can take from the outside to make better use of your own data. Further on, you can enrich the descriptions of all sorts of entities and objects that you deal with by using external information, and this way make it easier to interpret your own data, to add classifications that you don't have in your database but exist externally, or to add relationships between some of the entities that you care about, which are taken from the outside. So you have your database with your own customers, but you don't know whether there's some corporate relationships between your customers, whether one of them is subsidiary of the other, and whether these two customers actually have a joint venture in your own field. So there are plenty of ways in which one can enrich and add context to its own data by taking public data. And finally, you can use external data to gather broad awareness of different terms and concepts in a specific field. And that's useful for many purposes, but one of them is text analysis. So you can't make good text analysis unless you have a good oversight of a specific domain and have general understanding of, well, what Paris is about, and how the 3 or 4 or 5 different candidates that can match Paris in the text differ from one another, and how we can choose the right one based on the context of the document. That's the kind of knowledge that you can only get from a graph that is big enough and have all the relevant concepts in there connected with their fingerprints, which would allow for good disambiguation. That's the way in which big knowledge graphs can help text analysis, and from there on, we can use this text analysis to enrich the graphs, and that's basically the synergy and the loops around which Ontotext has been working, and we've been perfecting for more than 20 years. So if you do this kind of stuff right, there are plenty of areas and types of software systems that can benefit of this. So probably the most popular application is data management, because we say we have a graph database which can probably replace another database for the sake of data management. Well, that's true, but that's not the only one. And there's some types of data management where graph databases help, and others in which are less helpful. So, well, probably the most popular application of graph databases is we put some data together and we do some analytics, and we search path in the graph, and we do other things. What we've seen much more often in practice is that graph databases, particularly semantic graph databases, are good for management of complex master data or scientific data, where you have these quite often millions of concepts that you have to deal with and to use while analyzing some even bigger data using these reference structures. So master data and scientific metadata, these are quite useful for many data management tasks. They are also very useful for content management. So the best way to make good text analysis and enrichment of documents, be it clinical trials reports for drugs or business news, is to have a good reference structure, a good knowledge graph to use to analyze these documents and generate extra metadata and annotate them and interlink them. So that's a way in which specific kinds of data management can help content management. There are also a lot of relationship with knowledge management. So whether you're dealing with enterprise taxonomies or product catalogs or technical knowledge, quite often the end purpose of managing an enterprise taxonomy or controlled vocabulary is to end up with better precision search or better recommendation. That's on its own, probably part of the content management part of the spectrum. And so the names are not so important, but what's important is that having the conceptual structure in the middle, right, actually allows you to basically facilitate some interplay between your different systems, and some document management systems that you have here and there, and enterprise search tools over there, and the product catalogs developed by a completely different team. So all these different flavors of information management within the enterprise can be properly interlinked and hosted by a metadata management platform that uses knowledge graphs. What we see as application that is coming up more and more often, all sorts of applications related to industry infrastructure. And I'll show you a more detailed version of this graph, where you can see the same top-level categories, but a bit more detail on the specific applications. So you can see, infrastructure management, what we already mentioned about building management, supply chain management, and so on and so forth. So most of these separate applications, they require a lot of attention. There are companies which already do this. So we as Ontotext, we don't believe we should be the ones who do it all. We believe we should find partners and develop our technology in such a way that it can cover the requirements for all these different applications, and stay where we are with the core technology without getting ourselves spread too thin, and getting as big a partner network as possible. So even without going in the applications, if we look at the different capabilities that a knowledge graph management platform should have to enable all these different applications, you see that's a very, very busy graph. So we have plenty of things that should be possible at the phase where you're building your graph, all the way from having an ontology editor, taxonomy editor, or data catalog, or ETL tools to put the data together. Obviously, there is a need of a database engine to take care of storage and indexing and some of the operations. There is a lot of middleware work to be done for access, APIs, federation, and interoperability across different applications and systems. And at the end, usually you're doing all these things to end up with better knowledge exploration or knowledge management capabilities, or with better analytics, one way or another, all the way from text analysis to logical inference and many other things. So again, our decision was that well, we know what we're doing ourselves, and we denoted it with orange on this capability map. And there are quite a number of things which we intentionally said, no, we don't do this. We have partners who do this better than us, and we want to work together and to build a technology ecosystem where you can get all this covered by tools with clear responsibilities and good integration. So at this point, I want to talk very briefly about the schedule for the next couple of days. We have this first session, which is single track, Francois, myself. Next, we'll listen to George and Adiotis. And at the end of this session, we have Vasil Momchev, our CTO, who will be talking on, again, technology ecosystem and roadmaps. Then we have half an hour coffee break, and then we break up into different tracks. The business applications track, the last 2 hours for today is dedicated to life science and publishing. And tools and platforms track is dedicated to technology for building and managing graphs. Tomorrow we have similar structure. We start with a keynote by Dani Vandacic from the founder of Wikidata, and then we again split into business applications and tools and platforms tracks. So the first couple of sessions here, the first session in business applications is for verticals industry and government, and the second one is financial services. On the technical track, you first see several knowledge management and exploration tools, and then a range of search analytics tools. So please explore the program and try to book your sessions, because it's a lot of stuff and it's easy to forget, particularly in a virtual environment. That's where I'll finish. I'm not going to tell you about the small print now, but I'm available through the event, and you can reach out to me at the booth or just contact through the platform. Thank you.
Okay, thank you, Nasu. It's now time for the questions. While you were talking, actually, there were pretty interesting questions also in the lobby for some reason, but I will try to pick up some of them. Probably it's too early in the event, and the Bart was the most active on the questions. So actually, he touched the part which you didn't cover, and it was highly, I assume data can be highly distributed but also highly combinable, which also push the questions in the direction, what's the data locality and the data ownership, and how you query this type of distributed data.
Well, there are situations in which virtualization is not avoidable, just because you cannot easily transfer the governance and the control on a specific type of data. And then you just keep the data where it is and do it in a virtual manner. And that's something that we also do in many projects, and which GraphDB supports. We should be aware, though, of the limitations. When you have a query which reaches out to external database system or external source, this query cannot be optimized, essentially, because for database engine to optimize the query, you need to have statistics. Mm-hmm. And when you're reaching out to data that's somewhere remote, you don't have these statistics. Apart from the cost of transporting this organization and making all these remote calls. So yeah, there are many cases in which no ETL approaches with leave the data where it is are unavoidable. But then we should the data architects should be very careful on how different workflows and queries are designed to keep it bearable in terms of performance.
Okay, so one last question, because we have less than 30 seconds. What are the ontologies to enrich company data? I mean, if you have a company data, how you can classify them in new type of ontologies?
Well, that's very good machine learning task to classify and reclassify companies by industry taxonomies, of which there are many, and none of them is very good. Otherwise, speaking of company data, you can visit the WAS session tomorrow, because there you have presentations about FIBO, the financial industry business ontology, which touches on this, and few other interesting talks on the subject. So,
okay, thank you very much, Nasu. Yeah. I really appreciate your approach and how you gave the positive, but also when to not use knowledge graphs. See you in the next session. Thank you.
Thank you.